So today we will learn on rule of differentiation. So we have product rule, quotient rule, and also chain rule. So we will go deeper one by one, and first let us look on product rule. So when do we have to use product rule to differentiate? Okay, when we have two different functions or separate functions combined together by multiplication. For example, you have exponent x sine x. So exponent x is your u, sine x is your v. You can also change the place. Or maybe you have x ln x. Okay, it's two different functions. X is polynomial and ln x is logarithmic function. So u, v. Okay, it's multiplication, so you need to apply product rule. You cannot just simply differentiate separately. And then maybe we have what else? X cos x. So this one also u, and this one is v. So what is the formula for product rule? So it's u v dv dx, meaning you differentiate the v, u times v prime plus v times u prime. So d over dx. Okay, if you want to write in this form, it will be like this. A, B, C. Let us solve for A here. So your y is equals to exponent x sine x. So u is equals to exponent x. Your v is equals to sine x. So your u prime is you differentiate exponent x respect to x, you'll get exponent x, and v prime you'll get cos x. So now we just put in the product rule formula. So you'll get exponent x cos x plus exponent x sine x. That's it. You can simplify if you want. You can just factor exponent x. So that's it for product rule. Okay, so let's take a look at more examples. So now we want to differentiate this function. You see, you have two separate functions. Okay, this is your u, this is your v. So you will use product rule. You will get your u. What is your u? What is your v? It's x squared minus 2. V is equals to 3x power 4 minus x. U prime is equals to 2x. V prime is equals to 12x power 3 minus 1. So now you will substitute in the formula. Your dy dx is equals to uv prime plus vu prime. So the answer is x squared minus 2 12x over 3 minus 1 plus 2x 3x power 4 minus x. Okay, maybe we want to simplify it, so you will get 12x power 5 minus x squared minus 24x power 3 plus 2 plus 6x power 5 minus 2x power 2. So now you will simplify this, x power 5 with x power 5, so you get 18x power 5, x power 3, only one here, minus 24x power 3, x power 2 with x power 2, so minus 3x squared, and then plus 2. So that's it. That's the answer for this derivative. Okay, you can try to do or I will show you this. U is equals to x squared, V is equals to sine 4x. So your U prime is equals to 2x, your V prime is equals to 4 cos 4x. Okay, so your dy dx now will be 4x squared cos 4x, so you multiply them, plus 2x sine 4x. So that's it. Okay, now we move to quotient rule. So we will apply quotient rule when we have type of function like u over v. For example, maybe you have y equals to exponent x over sine x, for example. Or maybe you have y equals to sine x over x minus 2 squared, for example. Or maybe y is equals to x plus or x minus 1 squared over ln x. So it's separate functions and they are combined together by division. So we'll use this quotient rule. So another way of writing it is v u prime minus u v prime. Oh, sorry. So it should be v u prime minus u v prime. Yeah, it's right? Divided by v squared. Okay. So you need to memorize this formula for quotient rule. Okay, let us take a look at the example. Okay, here we write again. This is vu prime minus uv prime over v squared, the formula. Okay, so here the top function will be the u, at the bottom one will be v. Okay, so your u is equals to x squared plus 1, your v is equals to x power 3 minus 2x. So your u prime now is 2x, v prime is equals to 3x squared minus 2. So in order for you to use the quotient rule, the dy dx, okay, we use this formula, is equals to vu prime, so meaning this one, 2x multiplied by x power 3 minus 2x minus x squared plus 1 times 3x squared minus 2 over v squared, so x power 3 minus 2x squared. Okay, that's it. If you can simplify, you simplify. So in this slide, I will not show it. Okay, now for b is the same thing. This is u, this is v. So u is the one on the numerator, v is the one on the denominator. Okay, I hope it's clear. So u prime is equals to 3x squared, v prime is equals to negative 2 sine 2x. So your dy over dx is equals to 3x squared times cos 2x minus or plus 2x power 3 sine 2x. That's it. That's it in the simplest form. So you can stop there. So now it's chain rule for composite function. So composite function is something like we have a function in another function. For example, we have f gx here. Okay, so we will denote the inside function as u, and the formula for the chain rule is this one. Okay, for example, maybe you have y is equals to exponent sine 2x. Okay, in the exponent function we have we have sine 2x as the inside function. So here the u is equals to sine 2x. So you need to find dy over du and du over dx, differentiation rule. So here your u is equals to sine 2x. So u du over dx is equals to 2 cos 2x. And your y, we need to write in terms of u. So it will be exponent u because u is equals to sine 2x. So dy over du is equals to exponent u. So now we use the chain rule. So dy over dx is equals to dy over du times du over dx. So the answer is eu multiplied by 2 cos 2x. So now you cannot leave the answer like this. You need to substitute what is u. So now u is sine 2x. So you put 2 here, cos 2x. Okay, that's very simple. So there's another alternative for chain rule, which is called outside inside rule. So outside inside rule is we treat it as we differentiate the main function and then multiply by the derivative of the inside function. For example, we have now here y equals to exponent sine 2x. So dy over dx is equals to, so if we differentiate exponent, we will get the same thing, right? Sine 2x. Okay, then you multiply by the derivative of this function, which the sine 2x, the inside function, you will get 2 cos 2x, right? So if you want to write it beautifully, it will be sine 2x cos 2x. Yes, exactly the same. It's just that is the alternative method. So, but if you ask to use chain rule, so you need to use these. Okay. So let's look at the example. More examples. So now you see we want to differentiate this function y equals to ln 3x. So we have normally we have only ln x, ln 2x, ln 4x. But now we have ln 3x minus 1. So the inside function, so this is called composite function. The inside function is the u. Okay. So again, chain rule is dy dx is equals to dy over du times du over dx. So now your u is this one. So you write u equals to 3x minus 1. So your du over dx is equals to 3. Y in terms of u will be ln u. So dy over du is equals to just 1 over u. So now you will find the dy dx. Use the chain rule. So you will get 1 over u multiplied by 3. Well, it's very simple. So the answer is 3 over u, or we substitute the u, get 3 over 3x minus 1. So that's the answer for your dy dx. So how about y? So for y, the inside function is sine 3x. So first let us change in power form because there's no formula for us to use to find differentiation of square root. So we need to change it in power. So square root is equals to power 1 over 2. So now your u is equals to sine 3x. Your du over dx is equals to 3 cos 3x. Your u or y in terms of u is equals to u power 1 over 2. So your dy over du is equals to, Okay, we bring the power down. 1 over 2 u 1 over 2 minus 1, which is negative 1 over 2. So now your dy over dx is equals to dy over du 1 over 2 u negative 1 over 2 multiplied by du over dx. So now you will simplify it. You substitute back sine 3x equals to u. So you get sine 3x power negative 1 over 2 divided by 2 times 3 cos 3x. So we will now simplify it. So this one we can change 3 cos 3x over 2 square root sine 3x, because the negative, when we bring it down, will be positive. So that's it. Okay, thank you very much. If you have any problem, just leave it in the comment.